Alright guys, so today we are doing kind of like word problems, a lot of shapes, some geometry, so it's going to look a little scary, but we're going to get through it together. So this says, a square is inscribed inside a circle. So that's what I drew over here. This is a square inscribed inside a circle. And now it says, write the area of the square as a function of the circle's area. Oh my gosh, what does that mean? Well, if we have something that says f of x, right, that's a function of x. So we're going to do something similar, but with our square and our circle. So if the square's area, right, the square's area, I'm going to write that as s. I don't know what that is yet, but that's what I'm going to write. The square's area is a function of the circle's area. So if the circle's area, let's just call that A. If this is a function of the circle's area, right, it might look like something like that, like f of x, s of A. It's going to mean that s equals something, some weird stuff where I plug in A. Right, I know that's still confusing, but hopefully as we go through, you'll kind of see what I mean. So first, before we try to think of it as like the function of something else, because right, that's like a lot, let's just do writing the area of the square, just without this part. Don't worry about this part yet. That'll come in handy later. Let's just do, what would the area of the square be? Well, I don't know what each side is, right? I don't know what the sides are, so let's just call it x for now. Right? I'm going to call that x, and I'm going to call that x. So it's a square, so both sides are the same. So the area of the square is the length times the height of the square, or in other words, x times x. So the area of my square, and I'm going to write that just so we're all clear with an S. The area of my square is x squared. Alright, cool. You're like, yeah, I know. But is that a function? Is that a function of the circle's area? Have I plugged in the circle's area into this? Or do I see that as a variable? No, I only see x as a variable, so I'm not really done. So let's just focus, before we focus on like kind of combining the functions, again, I know this sounds weird, just like hang with me. Let's just find what the circle's area would be. Okay, well, if you remember the area of a circle, and I'm going to call this A for the area of the circle. The area of a circle equals pi r squared. Do you remember that? Hopefully you do, but here it doesn't say that anything is, it doesn't tell us what the radius is, so let's just leave it as a variable. Cool, so I'm going to call that r and call that r. Alright, so now that we've kind of seen that, I hope you see that our goal is to write s is equal to a times something, or something divided by a. The only variable that I want in my formula is going to be a. So I can't have like, it's ax times r. No, I don't get those variables. I can only use the variable a. Oh gosh, that's going to be difficult. Because like, look at that, has an x. That doesn't even have an x over there. That just has like a radius. So how am I supposed to tie those two together? Well, okay, let's do it this way. So if I can rewrite this using a radius, there's a few ways. All right, what I'm gonna do is I'm gonna rewrite this, and using, instead of x's, I'm going to write it with r's, and then you'll see what I'll do. So let's do that. So let's rewrite this, but using r's instead of x's. So how do we do that? Well, notice this triangle right here. But from the Pythagorean theorem, you know that this side squared, so x squared, plus this side squared, another x squared, is equal to this whole side squared. Well, that whole side is 2r's, so that squared should be the same based on our Pythagorean theorem, right? So what this means is that 2x squared is equal to, I'm just going to leave it like, actually, no, maybe I will. I'll distribute this. So this is 2 squared is 4, r squared is r squared. Yay! Okay, so 2x squared is equal to 4r squared. And I'm going to write Pythagorean theorem over here so we remember why we got that. And then I'm going to divide by 2 on both sides. So I'm going to get x squared is equal to, well, let's see if I divide by 2, that'd be 2r squared. So notice now I've got, let's change that to yellow. I've got an x squared, and up here I also have an x squared. So instead of having an x squared there, since that's the same thing as 2r squared, I'm going to write this as 2r squared, right? Hey, you know what, we're doing pretty good, because now I have the area of the square with, okay, so I still have a variable, right? Because the only variables we want in our formula at the very end should be a's. I had x's before, that was really annoying. Now I have r's. I have r's there, but I still don't want r's, I actually want a's. Well, okay, you know what? Let's take a look at this other equation we have now. So I have a is equal to pi r squared. Hey, notice how there's an r squared over here and an r squared over there? So maybe if I change around some of the numbers, I can like plug stuff in, right? So I don't want this r squared there. I'm going to want to plug in something for that r squared. Well, so what does r squared equal? If I divide by pi on both sides over here, I get that r squared, actually I'll write it like this, a over pi is the same thing as r squared. It's the same thing. So now I see an r squared there and I see an r squared there. So I can plug in, instead of an r squared here, that's the exact same thing as a over pi. So I'm going to write a over pi here. And now look at, now I have my area of a square written as a function of a, because that's the only variable there, right? I know some of you are like, what about pi? Is pi a variable? No, pi looks weird, but remember that's just the number 3.14159, blah, 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 blah. So it's just a number. The only variable here is a. So I've written my area of the inscribed square as a function of the circle's area. We're happy. Yay! Yay! So the real key for these problems is you're supposed to find how two different things that look kind of unrelated are actually related. We were able to relate these two by changing x's, or by finding how x's and r's were related using the Pythagorean theorem, which might come up a lot. So let's go ahead and do another example, or another example of a word problem. Might not be the exact same this time. So it says 4 pieces of some length x are cut from a 4-foot length of wire. Okay, whew. Gosh darn it. Okay, you know what? Before I even like read, cause I don't know how you guys, I always have to break up word problems. So before I even move on, let's just focus on that one sentence. So it says 4 pieces of some length x, blah, blah, blah. Okay, here's a length of wire. Okay, so I've drawn that length of wire right here. And I know that that's a 4-foot long piece. And now I'm saying 4 pieces are cut from it. But I don't know how long they are, right? So I'm just going to draw it like this. So that's one of length x, another of length x, another of length x, and another of length x. Okay, cool. We kind of dealt with that first sentence. We know what's happening. The second sentence says the 4 pieces make the 4 sides of a square. Oh, so this all together will be a square. Okay, that one wasn't too bad. What about this one? the remaining piece of wire is bent into a circle. Okay, so my guess is like this thing is like bent and shaped to make a circle. Now, before we move on, yeah, I know it's a circle, but do we have any information on that circle? At first glance, it seems like no, but well, let's look at how long is this piece? The whole thing was 4, and if we take away each of those pieces, we take away those 4 x's, I'll be left with how long that piece is, right? So my piece right there, let's do it in a different color, is 4 minus 4x. Oh, okay. So if that whole piece is taken and bent into a circle, that means my circumference of the circle, my circumference is 4 minus 4x. I might just draw that so we know it's the circumference, right? I mean, that means the distance around the circle. So it's not the area, it's not anything else, it's not the diameter, it's the distance around the circle is 4 minus 4x. All right, so we actually know that much information. So let's keep going. It says, write the area of the square as a function of the circle's area. So we're going to do something kind of similar like what we did before. So I'm going to write S for this area of the square, and I'm going to write A for the area of the circle. Now, I know some of you are like, why aren't you writing like C for circle? Well, because C, when we're talking about circles, usually means the circumference. And I didn't want us to get confused. So that's actually why I was writing A for the area of the circle. So I have let's just write down just like the basic formulas we know. The area of the square, just like before, it's this times this, right? It's x times x, or otherwise x squared is how we might want to say it. And then what about the area of the circle? Well, we know that that is pi r squared. Okay. Any other problems we run into, you guys? Well, maybe some of you guys are looking at this and you're going like, okay, I get that that's the radius, but we weren't told what the radius is. I have no idea what the radius is. That is a fair question. So what we're gonna have to do, just like before, we found some way, right? We found some way that x and r are related. We're gonna have to do the same thing down here. We're gonna have to find a way that x and r are related. So unlike the other one, the square isn't inside the circle, right? There's no nice triangle connecting them. So how else could we relate the radius, and I'm going to write that right there, to x? How could we do that? Hey, well, the circumference of the circle has x's in them, and the radius has this r, so maybe we can use the circle to somehow connect x and r. So remember that if you don't remember this, hopefully this will be a nice reminder, the circumference of a circle is the same as 2 times pi times the radius. And what's the circumference in this case? The circumference in this case is 4 minus 4x, right? So we know already that 4 minus 4x is the same as 2 pi r. So now we have them related. Cool. So there's two things we could do. We could solve for x or we could solve for r. Since we solved for, let's see, we plugged in x squared last time to get something with r, I'm probably going to do the same thing this time and plug in something for, I'm going to plug in something, or I'm going to try and get r all by, I'm a mess. I'm going to try and get x all by itself to then plug in r. So here's what we're going to do. I want to get x all by itself. What should I do? Let's hit minus 4 minus 4. I'm going to get negative 4x, right? I'm just solving for x right now. That is all that I am doing. And then if I divide by negative 4, I get x is equal to 2 pi r minus 4 over negative 4. And I'm going to rewrite this a little, just simplify it, right? This means the whole thing divided by negative 4. So that means 2 pi r divided by -4 plus -4 divided by 4. -4, sorry. -4 divided by -4 is 1. Sweet. 2 divided by -4 is -1/2. And then I'm going to rearrange these a little bit to look like that. Luckily, this is a recorded one, which means you can just go back and re-watch this. Yay. All right, cool. If it's confusing. Okay, so now I have x is equal to this crap. So what am I going to do? Well, remember I wanted the whole point of me doing this was so that I could replace the x up here with something that has to do with the letter R or my radius. So that's all I'm gonna do. Where you see that X, instead of the X, I'm gonna plug in this random stuff. It's not random, but you know. So I'm gonna write this as S is equal to, instead of X squared, I'm gonna write 1 minus pi R over 2 squared, okay? All right, now, just like before, what was our whole point of doing, like, what are we doing in this problem? Oh yeah, we want the square as a function of the circle's area, right? We want to write S is equal to something that only has A as a variable. And right now, it doesn't have A as a variable, it has R as a variable. Gross. So we need to change it a little. And hopefully this is looking kind of familiar, because I know some of you are going, well, oh, wait, hold on. I recognize this because I could just divide by pi. I get a over pi is equal to r squared. Now, the annoying thing here is because this doesn't say r squared, or it doesn't say r squared all by itself, you need to get just r. So that's kind of the annoying one. So it's okay there. We're going to take the square root. And then we get the square root of a over pi is equal to r. And I know some of you are going to stop me and say, isn't it plus or minus a square root of a over pi? And then usually it'd be like, wow, nice job, you caught on. But you don't have to worry about that because r is a length. Like if I was like, okay guys, I'm -5 feet tall, you'd be like, what? Right? Because when we talk about lengths, we're only using the positive. So I don't have to worry about the negative because the radius is a length. It's only going to be positive. So now look here. I've got this is equal to r. Well, now I can get rid of the r here so that there's only a's in my equation. So if I rewrote the area of the square again, let's see, I'm just going to plug in, instead of that r there, I'm going to write, it's going to look real gross, but it's okay. Square root of a over pi divided by 2 squared. Okay, I know that looks super gross, and some of you might want to distribute it out and simplify it. You can totally do that. I'm not going to do that because this video is already at 18 minutes, and I don't want you to be annoyed with me. If anything's confusing, go ahead, it is a lot. It's a lot. Soak it in, rewatch it if you need. Basically, as a wrap-up, all we did, I just wrote out what is the area of the square, what's the area of the circle, and then I found how x and, I'm going to do this with a highlighter, I found how x and r are related so that I could change this, I could keep changing it until it had just a as a variable. There's no r in there, there's no x. My area of a square is some crazy stuff with only one variable. And that's the same variable I use for the area of my circle. So now I've written the area of the square as a function, as a weird thing, of the circle's area. Okay? Oh, that was tough. I know, but I thought you guys might want an explanation because it was on your homework and all this stuff. So hopefully this helps. Come to office hours if you need more help, and see you all soon.